Hello, everyone. Thank you for coming for this session. I like to walk a lot, and this is where I'm going to cover the slides. So I'm going to have to restrain myself to this area. That's unusual. Anyway, welcome. Thank you very much for choosing this talk out of all the interesting talks at Devox. I hope you're going to enjoy it. I hope you're going to learn something new, and hope you had a good time so far and going to have even better time from now on. All right, my name is Milen Dyankov. I work for Exonic, and I will be talking about location transparency today. So, just for the record, how many of you are familiar with the term location transparency? Okay, of those of you who have your hands up, how many of you have done any networking? Yeah, that's what I thought. Typically, this is a known term for people who have done any sort of networking because it's a well-established term in networking. But when we talk about generally about software development, it's not so much. And that's why I want to kind of make some explanations about what actually means and how it is applied in software technologies. Well, let's start with a little bit of information about me, so you know who is the guy who pretends to be very smart. That's me, Milen Dyankov, and this is where I live. This is my house, or actually it was, because it changed. But it existed in a city, in a very convenient location. My kids love it because all their friends are around and stuff like that. My wife, though, she always dreamed to have a house at the seaside, and she wasn't really happy with this. So we kind of made that hard decision. We cut a piece of the house and move it on the beach side. And now she lives on the beach, and she's super happy about it. Now, I'm not really a beach person. I don't like the sea that much. I like mountains. And I was like, hey, we can do this for her. Why not do it for me? And so I cut another piece of the house and move it in the mountains. So I have like a beautiful view from my bedroom, and I love it. Now everyone is super happy. Kids are happy because they're with their friends. My wife is at the sea. I'm in the mountains. It's been marvelous experience. The only issue is we have to drive several hundred kilometers to meet for a family dinner. But hey, it's not a big deal, right? Did you buy that story? I mean, it's ridiculous, isn't it? Well, I'll tell you a story that you will buy. Here's my application. It was a beautiful monolith working just fine. But then we thought, like, hey, this little piece here, it's not really happy, it could scale out. So we cut that piece and move it into a separate deployable unit. Right, independently, distributed, whatnot. And then we cut another piece and we put it over there. And now everything is working great as a distributed microservices, whatever system. Do you buy that story? Now that's much more believable, isn't it? When we talk about software systems, we just can slice and dice and deploy and everything works beautifully. Until it doesn't, until you realize that all the things are actually interconnected and where they are deployed doesn't matter that much, right? And you have things which we typically call a distributed monolith. And then that brings all sorts of issues and whatnot. So how many of you have been through that process? Come on, yeah, that's the full room, exactly. Okay, so I'm not going to bother you with a solution to that particular problem because, I spend most of my time as a software consultant, and the only correct answer a software consultant can give you is it depends, right? But one thing struggled me when I first used that analogy with the house. I was like, how it is that every time we talk about software systems, we don't see that nonsense, but when we transition things to physical objects, like the house example, you can immediately sense the nonsense. You can immediately tell, that's bullshit. Like that doesn't work that way, right? You can immediately tell that. You don't have to be, you don't have to have a proof for that it doesn't work, right? You can immediately see it. But when we talk about software systems, it somehow seems like everything's possible. You can just cut pieces of it and deploy it somewhere else, and it's fine, right? And so why? And the more I was thinking about it, the more I came to the conclusion that it has to do with some terms that we are using in software development and software engineering, the first of which is coherence. Now, you probably have heard about coherence a lot of times. And if I was asked to ask every single one of you what is coherence, there probably going to be at least 10 different versions of it. But essentially, by definition, coherence is the quality of being logically consistent. So you have multiple things that are logically consistent. They're kind of a one thing, right? They're forming something that is a whole, a unified whole. So just to give you an example again with the real world, imagine you have to do a trip with a public transportation, like a train, for example. And then you go and you want to sit on the train, and they go like, yeah, no, you sit on that train, but your purse is going to travel with a different train, and your coat is going to travel with another train. And you would be immediately like, that's nonsense. Like, no, my personal belongings will travel with me because that's what coherence is, right? We are kind of one thing. Well, we're not one thing, but we want to be together on that trip, right? So that's what coherence is. These objects, they are so tied together for whatever logical reasons that you don't want them to be apart. But we don't talk about too much about coherence in software engineering. What we talk about a lot in software engineering is coupling. And coupling is bad, right? Right. Okay, so coupling is different than coherence because coupling is the act of making things together for a particular reason. They don't logically belong together. They don't have to be there to form a coherent thing, right? But it just makes sense in a particular case to couple them because of efficiency, performance, convenience, whatever the reason is. So you think of it like the cars of the train, right? They're independent objects, and they are coupled. They are tied one after another for the purpose of having a single engine to be able to move the entire train, right? But it doesn't have to be this way. Technically, you could put an engine in front of each car and deliver them independently, right? It's just not convenient, not efficient, not optimized. So you deliberately couple things to achieve certain things, like performance or some sort of optimizations. So coupling is different than coherence. Now, there is another term, which a lot of you probably never heard of, and that is connascence. How many of you have heard of connascence? All right, that's what I thought. One person, okay. So the first time I encountered that was from that book, The Fundamental Object-Oriented Design in UML by Mailer P. Jones. And it kind of opened my mind to start seeing differently relationship between objects. So what is a connascence? A connascence is when two or more objects are, in a sense, born and sentenced to live together, right? And they form like some sort of a connection which is not immediately obvious, but they have to evolve together through their life cycles, right? And it's hard to explain, but consider this example. The wheels of a train and the railroads, right? Those are completely independent things. They're produced by different companies, right? They have absolutely nothing in common in terms of like life cycle and whatnot. But if you decide to change the shape or the wideness of the wheels, it's not going to work unless you also change the rails, right? And vice versa. If you want to change the rails, then you need to do something with the wheels, right? So those are technically independent objects, but there is a connascence between them. They need to evolve together. They need to be changed together, or otherwise, if you change one and not the other, things will not work anymore. So that's a very interesting example. We don't build trains, luckily. So we do software. So let's see how that works with software. Here is a very complicated piece of software. I hope you will make sense of it. It's part of an application for buying tickets for attractions. And so basically, you want to buy a ticket for an attraction, you pass it as an argument and whatever. Very complicated piece of code, as I said. There is a connascence in this code. Can you see it? You probably can't, so let me help you out. There is a connascence of name. Now, you have a field, which is called main attraction, and you have an argument to the whatever function constructor that thing is, that is also assigned to that field. So you have a declaration and an assignment. And you can't change the name in one place. That's two different things, you know. But if you change the name up there, you have to change it down there too, and vice versa. Right? You can't just change it in one place and expect it to work out somehow magically. There is another connascence in that code. Can you see it? As a connascence of type. Now, you must maintain the same type of the field in the argument. Right? If you decide to change the type, any of those, then the code stops working. Right? So there is a connascence. So there are the two types of connascences that we deal with all the time and we never care about. And the reason we never care about is because we have the tools that help us deal with those. We now use IDEs and stuff. Like back in the old days when I started programming, renaming things like was painful thing. Now you go to your IDE, do refactoring, and it changes everything for you, and you're good to go. So that's why those two types of connascences, like connascence of name and connascence of type, are what we call a low-level connascence. You don't care about that much because that's something that you can relatively easily deal with. But there is a different piece of code in here. Now, the above is basically getting a ticket, the method that is booking a ticket for a list of attractions. And this is how you, below is how you call it, right? So there is a connascence here that is not a connascence of name or type. It's a different type of connascence. Can you spot it? Well, probably you can't, so let me help you out. It's called the connascence of algorithm or connascence of convention. So what we have up there is we have the assumption that of the list that is provided, the first argument is the main attraction and all the rest are the other optional attractions, right? And that is exactly how we provide that. We put our main attraction first in the list and pass the list. Now, if that algorithm or that assumption or that convention changes in one place, everything crash and burn. Right? You have to maintain the same convention, the same algorithm now in two places. Now you need to know how that method works before you can actually pass an argument to that. And you will be like, oh, come on, we can fix that easily. We're just going to provide a special attribute for the main attraction, right? And then all the other attractions. Well, this is known as a connascence of position. It's very similar to the previous one, but it's no longer about the algorithm, but about where in the argument list you put stuff and you expect to find stuff, right? So you have to maintain the order here for things to work. If you want to change the order, things will not work anymore. Now, there are a lot more types of connascence, which I'm not going to spend the time to walk you through all of them. There is a connascence of execution, a connascence of timing, a connascence of value. So there is, for example, a situation where you expect that two different objects maintain the same value, otherwise things break. Or that they change at the exact same time, otherwise things break, and things like that. One that it's very interesting, in my personal opinion, is a connascence of difference, or also called contrascence. And that is because we don't think about it normally, but with time, it shows in a very ugly way. The contrascence is basically the idea that when you use something, you can't use it anymore. So when you name your variable name, right, you can't use that variable name for something else, right? And for as long as you're the sole developer of the code base, that's probably not a big deal. But when you start merging code bases, codes from different places, then you realize that actually contrascence is a problem because the thing that other module expects, the name or the type that other module expects, already exists in here, but means something else. and you can't use it, right? And that is where very interesting things happen. So, with this basic definition of connascence, now we can start thinking about how it relates to coherence and coupling. Do we have a connascence because we want coherence, or because of a coupling, or neither? Yeah, that's not an easy question to answer. How many of you have read this book? Okay, good. Fair amount of people. So in that domain-driven design by Eric Evans, he defines a term called aggregate. And an aggregate is essentially a group of objects that are treated as a whole with respect to changes. Now, let's compare that with coherence. If you compare the definitions, you have associated objects here, things forming a unified whole over there, treated as a unit. There's quite a lot of similarity. So basically, the aggregate is a formal definition of a group of objects that is within some boundaries, right? And what is within these boundaries is no one's concern, right? So it is coherent to some extent, right? But it has an object that interacts with the outside world, and there you can't expect coherence, right? So you can imagine it like this. There is a group of objects, they're somehow connected within these boundaries, right? There is one that talks to the outside world, right? And then inside, you can have higher connascence. Like, how are these objects connected to each other? It doesn't matter. Because whatever you change in there should never ever affect anything outside, right? You can deal with higher connascence in here because you can do, it's your stuff, it's in a small piece, relatively, and then you can do whatever it takes, right? But when you talk to other objects, and then that's an example, it doesn't have to be an aggregate, by the way, anything that gives you this boundaries can work. So as soon as you have a coherence boundaries around some objects, it doesn't really matter how they're connected. You connect them the way that works best for you, right? And so you have higher connascence in within. But what you want is a lower connascence when these objects talks to each other. So you don't want to have anything other than connascence of name or type when you're exchanging data between those objects or systems or whatever they are. All right? Because if you do, and you want to make a change, that change hurts, right? Because you don't know. I mean, that's a simple diagram. Here you have two things, but this can be 20 or 200, right? And if there is a higher connascence in the middle, it could be a very painful experience to try to figure out what else in a system needs to change. So that's the general rule. You have those coherent objects, groups of objects, and you exchange some data, they exchange some data between each other, and you expect that the connascence of name and type only exists when there is this exchange. Now, what about connascence of location? Now, that is not a term that originates from the book that I showed you earlier. It's a term that I started thinking sometime later. We are very happy with drawing diagrams like this, like boxes and cylinders and then arrows. And I used to joke that the hardest part in software design is implementing an arrow, right? If you have a diagram and someone draws you an arrow, like this guy is going to talk to this guy, that is probably 3 months or 3 years, I don't know. It depends on how complex the system is, but it's an arrow on, easy, right? But so about the arrows, like, is there a connascence of location? Does this object need to know where that other object is located? Now let's talk about connascence of location. There is a piece of code in here that has, in my opinion, a connascence of location. Can you see it? This code works under the assumption that both methods are in the same class. Move one of those methods in a different class, and that piece of code doesn't work anymore. And you will be like, oh, come on, like with Java developers, we know how to fix things like this. We just create, classes, and then we just use that, from different class, right? That should work. It has another assumption. It has the assumption that the both classes are on the same class path or module path in the recent Java versions, and that's it. Move that class to a different class path, and that code is not going to work anymore. Right? There is, that's this. There is another connascence here, which we go like, okay, forget about it. We're just gonna do, RESTful, right? Forget about Java. We're not gonna call methods anymore. We're just gonna go fully RESTful. So I have a RESTful service, and I have a RESTful client, and I just call it, right? Well, first of all, this means that you now maintain the same configuration on both sides, right? So you need to know where that service is in order to call it, right? And then on top of that, you have a connascence of name, right? Because you can't just change a path, right, and expect automatically things to work. And between two components, that may not be an issue, but if you have a proxy server in there that needs to route paths and things like that, things become a little more complicated. But so you go like, let's go Kafka. And that's where pretty much every software engineer these days end up when they design things. Like Kafka is the solution for everything, right? And so we're just going to create a topic, and we're going to read a topic, we're going to publish a topic, and we're good to go and forget about the stupid connascence thing, right? Well, not entirely. First of all, you now need to maintain those topic names, and you can't just start publishing to a different topic and expect things to work, right? And then you also have the same connascence of type and name on top of that. And now you have it between three systems or more, right? Depends on which topic you define and where you define it and how you define it and things like that. So in all these scenarios, it's apparent that one component in some form or shape needs to know where the other component is located or how to reach. What is the path that leads from one component to another, right? And this is what I call location awareness. I mean, it could be an assumption. It's in the same class. It's in the same class path, right? It's in the same JVM, right? Or it could be explicit. It's on this path, on this server, right? But it is explicit or implicit. There is an awareness about where that other component is. So can we deal with that? If we do have a connascence of location, what can we do to mitigate the problems that this causes, especially when we move from one scenario to another? So just to make it clear, connascence is not a problem if nothing changes. You designed it and it works, right? It becomes a problem when you want to change things, when you want to go from a monolith to a microservice, when you want to extract pieces, when you want to do different types of communications. All of a sudden, there's assumption that something's on the same class path, something's on the same class or same package or whatever. That becomes a problem, right? That becomes apparent, right? So how do we deal with that? Well, let's focus on that piece in the middle that we call data. And data is kind of too big of a term. So let's call it message. Like, so we have a message, and basically we have communication via messages. Like one component sends a message to another, and reverse, right? And so this is the Kafka approach, right? That's why everyone jumped into the Kafka bandwagon, like, oh, just send messages and forget about things. But are all messages equal? I think they are not. We have at least three types of messages that are fundamentally different. There is commands, there is events, and there is queries. So what is the difference? A command is a message that you want to send to a particular component. It's not shouting out at the world. So if I want to do something here, I want a glass of water, right? Unlikely to say, someone please bring me a glass of water, right? I likely ask a person or, a specific individual or specific, I don't know, servers to do this for me. And that's what command is. It's targeted towards a specific component. And moreover, it expects some sort of response, like a minimal response that say, I will, I want, right? Because if you ask something to be done, you want to know, will or someone take care of it? Like that's the minimum amount of response that you expect. Now, events are the opposite. Events are basically saying something happened. Hey, folks, something happened. And you don't really care who was going to react to that. You notified the world about the situation and let them define their reaction the way that's more convenient for them. You don't expect any response. You don't expect anyone to go back to you and say, I heard you, right? It's just everyone's notified, do what you please, right? Now, queries, on the other side, are quite the opposite of these two. Because if you send a query, which is essentially a request for information, the only thing that you care is the response, right? I mean, like, what's the purpose of asking if you're not going to get any answer, right? So everything about queries is about getting the answer back, right? And this is where, for example, queries is one of those things where dealing with Kafka becomes really complex, because if you do everything like a message and it doesn't have the routing patterns implemented properly, then you do things like, I have a topic for queries and then other topics where responses are received, and then you have to do all sorts of correlation IDs and whatnot, right? So if your solution does not allow you to do this in a native way, the things can become really cumbersome. So here are the fundamental differences. A command is sent to a single handler. An event is sent to all interested components. And a query is sent to either one or several components, because you can send a query that several components needs to respond, and then you collect their responses, and that is the answer that you expect, right? The other fundamental difference is about the response. So when you send a command, you want a call, you want something back, and that is typically a confirmation, an ACK-NACK, I will, I want, right, kind of thing. When you send an event, you expect no results, no responses, because you just tell the world something happened and they do whatever they want. But when you send the query, the most important thing is the response, right? So there's fundamentally three different types of messages that you can use to communicate. So how do we do that? What about defining those types of messages as a POJOs, plain old Java classes? So we have a class, it's called issueTicketCommand, and it has some fields, main attraction, list of attractions, and that's it. It's a command. It basically says, I want someone to give me a ticket for this main attraction and this attractions, right? And then we have an event. An event is past tense because things have happened already, right? So it is ticket issued event. It notifies that something has happened. A ticket has been issued, right? And it tells you which ticket for which attractions and whatnot. And then you have a ticket attractions query, which basically says, give me the list of the attractions that this ticket allows me to go to, right? And the response, ticket attractions response, which basically says, yeah, that's for this ticket, that's the main attraction, and there's the list of attractions. So just plain Java objects, nothing complex in here. Okay, what do we do with these objects? Well, we need a way to send and receive those between components. So we need some sort of a message router, something that knows how to move those things around. And let's assume we have such a message router that's capable of doing this magic somehow. Then we can have components here that send those types of messages in being explicit about the types of messages they send. So in here, we will have a command gateway, an event gateway, and a query gateway. And then we can say a command gateway, send and wait, because in this particular case, we want this synchronous. It could be asynchronous. You can say send a command. And the command is the object that we defined earlier, right? That's what we want, all right? Or you can say event gateway, publish an event. And the event is the same plain Java object that we defined earlier. And the same thing with queries. You can say send a query, and I'm expecting a response type that is a single instance of this Java class, right? And so it's super simple. It operates on plain Java objects. You basically send this to a message router. And what a message router is supposed to do with this? It receives some commands, events, queries, and what? Well, it handles it should pass them to components that are handlers, that know how to deal with those things, right? But how? Well, you can register, let's imagine that you have a way to register such handlers. So you can say, I'm a command handler, and I know how to deal with issue ticket command. So and that is the argument of the method. So if an issue ticket command is received, you can send it to me, and I know how to deal with that stuff, right? Or you can register an event handler and basically say, I know how to deal with ticket issued event. If such event has been published, notify me because I need to do something about it, right? Or you can register a query handler and say, I know how to deal with ticket attractions query, and I will provide ticket attractions response as requested, right? And so there's a very simple way with annotations in this case to register such handlers into that message router. And so now the message router has the logic. Hey, I was like, oh, okay, I receive these types of messages from here, and I have these components in here who know how to deal with this. And so when the message is received, he knows how to route it. He knows the command needs to go to one particular instance. It knows that events needs to be distributed to everyone. It knows that the queries requires response, so it needs to route responses back and things like that. So a little bit smarter message router, so to say, than Kafka. And then you have this situation. So let's assume that there is some framework that exists that allows you to do things like that. And if you do things like that, what this gives you, right? Well, it gives you the ability to use a higher connascence within your components. So how things are wired in here internally, it doesn't really matter, because if you change this component, you're likely going to play with all of it, nuts and bolts and internal stuff, right? But it allows you to only use connascence of name and type when you exchange messages, because those are designed as a simple plain Java objects, right? And so there is no connascence of location, no connascence of anything between these components. You basically say, there is a message of this type with this name, publish, send, right? And then someone's going to handle it. And you don't really know where that someone is located. It could be in the same JVM, in the same class, if you will, or it could be in a distributed system across the ocean. It doesn't really matter from code perspective. Of course, it matters from performance perspective, like, network communication, serialization, and deserialization. Those are not cheap things, right? So, you have to take that into account. But from your code logic, from how your source code looks like, nothing changes. You're still sending messages and receiving events, commands, or queries, right? And so, if this could exist, why no one created it? Well, actually, we did. And several years ago, well, correct me, what is it? It was 2009. The CEO of Axonic came up with this idea that we can actually create a framework that does all this stuff, right? So if you like the idea of communicating between components this way, here is a framework that is an open source one that you can use. You just put it as a dependency and you start designing your system in a way that all the communication between components is gone through these message buses with commands, queries, and events. What this gives you is the ability to know where to slice things. So you can design it this way, and you can deploy it as a one big monolithic application, and there's nothing wrong with that. There's nothing wrong that components within the same application use this communication style, right? You just deploy one jar, var, or whatever it's the thing, and it works internally like this. But because you have now defined the point of high connascence and the points of low connascence, right? And you know where you can cut, right? You don't cut here because you know that's not going to work. It's going to cause you troubles. But this communication now allows you to grab this component and deploy it somewhere else. And so what you can do is you can put something that is a distributed message bus, a routing system in the center. And we created one for you. It's called Accent Server. And now the very same application, without changing a single line of code, can be deployed as a independent deployable units. And then Accent Server is going to do the routing between them. Right? And it's still components here don't need to know where the components over there are located. You can grab it and move it here and over there. It's going to work exactly the same way. Right? So that's what location transparency is. You are communicating between your components without having to know where they are physically. And it doesn't matter. Right? And it gives you a lot of flexibility when you build applications this way, because you can merge and distribute them as you find fit for your particular use case. All this works in Java, right? Or all the JVM languages. We have a lot of people using Kotlin, some using Scala and other things in the JVM land. So if you are in that land, this works for you. Accent Server is free to use. There is a single node free version to use. If you want more advanced, clustered, multi-context features, then that is where you need to get the commercial license. Or you can go with Axonic Cloud, which is essentially Accent Server in the cloud managed by us, and you pay as you go. So there are many different ways to do this for free or for small fee or for bigger fee. But if you're outside of the Java world, you kind of don't have any way to use that, right? Or you didn't, because there is the newest kid on the block, which was released just a couple of weeks ago, and it's called Accent Signups. And so what Accent Signup does is it translate this communication, this stuff that happens behind the scenes, so you don't see, to an HTTP API. And so basically it exposes an HTTP endpoint, and it can call HTTP endpoints, which allows applications written in any other language that can communicate over HTTP to now communicate the same way. So what you can do is you can design our application that, for example, commands are received by something written in Go, and they go to a Java application which handles the command, and then command sends a notification that is, I don't know, sent to C++ something, right? Or JavaScript is sending a query which is answered by a Java application, or I don't know, PHP application or whatever. You can mix and match. Right? Of course, it comes with an overhead of converting all this stuff to serializing, deserializing, and all that things. But it gives you the ability to build distributed systems across multiple languages. And so I'll leave you with information about those tools. As I said, Accent Framework is a fully open source framework for Java and JVM languages. Accent Server is a zero configuration router, so you just install it. It's a one jar file. You start it, and it works out of the box. Axonic Cloud, if you don't want to install, although as I said, it's just one jar file, but if you want to use it as you go, and then the signups is the HTTP bridge. For the Accent Server, and we have all pages for those products on the developer portal. So go there for more information. Now, I need to do a shameless plug before we end up this presentation, and that is that I'm particularly involved with the organizing of an unconference in Amsterdam on 27th of September this year. And if you want to learn more about those things, or people that would want to learn more about those things, and by those things I don't mean our products, I mean this type of build of software concepts and these types of building applications, we highly invite you to join us. We are trying to invite people not only from Axonic, obviously there's going to be people from Axonic, but we also want to invite people from other vendors and kind of have a common understanding how can we build more applications this way in more flexible and more location transparent way. So I'm hoping that it's going to be a very interesting event for sharing information between multiple vendors. So you're more than welcome to join us at Driven. And with that, I would like to again thank you very much for attending this talk. It was my pleasure, especially given the time of the day. So I think we have 10 minutes for questions. So thank you again, and I'm listening for your questions. Anyone? Yep, there is one there.
First of all, thanks for introducing the concept of Connascence.
All right.
Never heard of it. So the question I have, if you're not familiar with this kind of programming, could you list some of the anti-patterns that you see when people start using this?
Anti-patterns when they start using this, there's quite a lot of them, to be honest, unfortunately. So one is people, so first is like whether I presented aggregates here because it's a very, in my opinion, very good concept from domain-driven design. But you don't have to use aggregates. Like as with everything, it comes pluses and minuses. Like an aggregate introduces a boundary, which is a good thing. You want to have a boundary. But at some point in time, it becomes the time where you need to change that boundary. And that may or may not be complex or problematic, right? The other thing is with messages, like if people are not don't understand how things work very behind the scenes, they tend to go with, oh, just gonna send a whole object. We have someone sending like, I don't know, like 15 or 50, I don't know, megabytes of the message sites. And because there is, of course, a limitation, the default is, and they were complaining about framework not capable of like delivering big messages. I mean, you can set the message size to, a gigabyte, right? But you need to take into account that transferring a gigabyte over the wire every time comes with a cost, right? Then it's the problem with, in general, scaling the events, like how big they should be. Should I have one event with everything in it, or should I have 10 events with like, or every field? Like we see both extremes, right? Some people tend to combine everything in one event, and then some people tend to do it, basically a string per event, right? I mean, I don't know what's right, what's wrong. That is where you need to sit down with your domain experts, because the thing that I don't present in this particular presentation is that another feature of Axon Server is that it's also an event store. So every single event that goes through the Axon Server is persisted and hold there forever. Right? And so you need to take into account that, whether you want to use event sourcing or you don't want to use event sourcing. Do you want to keep events forever? How your objects are built from events and things like that. So it takes a little bit of wrapping your head around the concepts before you see all the benefits of it. But for the purpose of distributing applications, right? It is super easy to start. It's a starting point. And we actually have a lot of customers who move to us because they have monoliths and they are willing to split them into distributed systems. I deliberately don't like the term microservices. But it's hard, right? Because you start doing distributed, and all of a sudden, for all the reasons I mentioned, things break, right? So what you can do is you can keep your monolith and start changing the communication patterns within the monolith. Like, okay, these things will work now via messages, right? And then while you're still within the same JVM, it doesn't make any huge impact, right? And now you can, and then when you're done with this phase, right, you can think about what to distribute, what to deploy where, and things like that. So that is the benefit. But obviously, it's not unicorns and rainbows, right? It does need some experience, so to say, to be like fully successful with it. I hope that answers the question, because I can go with the patterns a lot, but let's give other people the time, the ability to ask questions.
First of all, thank you very much for the presentation, really interesting. What I was curious about is, can you give us any examples of companies that are clients of Axon, and what are the type of business use cases that the framework facilitates for them?
So I can give you some. Unfortunately, I can't give you the ones that I want to give you, because a lot of our customers are requesting NDAs, and we naturally sign those with them. So there's a lot of companies I would love to talk about, but I can't. Generally, the pattern is like you can imagine the most usual case, and that's what we imagine, would be any system that has a business requirements for auditing. Right, because if you have infinite event storage, you can go through the entire history of the application and then tell what happened. Right, so you don't have to build dedicated auditing solution. Right, we have some customers for which that is the case, but for most customers, the case is actually anything that, because most of this is used with event sourcing, to be honest. The case is with tracking history of things for a variety of reasons, right? You have let's say, how to talk about it without not talking about it. Inventory of things, right? And you need to know what happened to those things. And those things could be different things. Could be, for example, I don't know, objects in your warehouse, or it could be assets, physical or digital, right? And then, or you can have systems that are very distributed by nature, in a sense that it is just required by law to not put all the stuff in one place, right? So there's many different cases that leads to this. But those are the business reasons, right? From developer perspective, the most common reason is I can focus on my thing, and I can be sure that things will not break when I only work with my tiny little thing, for as long as don't interfere with the communication, right? There are ways to deal with that too. The frameworks allows you to do things like upcasters and variety of different things. So you can convert message types. Like if you need to change the payload, so you need to change your class to add a field or remove a field, and you already have stuff stored, then the framework allows you to register upcasters that can convert from one version of the object to another and things like that. But it's just, we're getting too deep into technical details now. 2 minutes. Oh, that's going to be a hard question.
Hopefully not. So location transparency doesn't really imply what you can call consistency transparency. So for example, if I issue a command within my process and it updates state, and I then issue a query for that updated state.
Right.
If in my JVM, this probability that I get the proper state back is pretty high.
Yeah.
But it won't be the case if I cross network boundaries.
Yeah.
So while I get location transparency, that's a nice feature. I do
and again, eventual consistency.
Yeah. And how do I sort of take that into account when I design my application for both in-process and inter-process.
Yeah, well, I mean, that's the same question of how do you deal with eventual consistency in general, right? I mean, if you want to be location transparent, yeah, that's probably something that I should have been more explicit about. If you want to do this in the distributed environment, then you're in the land of eventual consistency. So you have to deal the same way you normally deal with eventual consistency. Which essentially boils down to two things. Either you accept that and say, I refresh 3 times and it'd be okay, if it is okay for your application, or you block and you wait for a consistent state, or consistent, because you're never going to be in a fully consistent state, because that's going to eventually happen, all right? But you block and you wait for a consistent state from your point of view, from the piece of data that are important for you. But then you need to sacrifice performance for that. So it's hard to, I mean, both options are possible. The question is what works for a given business case, right? What is important for that particular application, right? Is it more important to give you some data, even though inaccurate or not fully accurate? Or is it more important to give you fully accurate data, even if you have to wait for it? Right? That's the universal dilemma of eventual consistency. I don't think we have any more time for questions. So thank you very much. We have a booth downstairs. I'll be at the booth as well as 2 of my colleagues. So if you have more questions, feel welcome to come and talk to us. Thank you very much again. Have a great evening.